Hi class, this is your review for your square root test retake on Friday. We're going to go over some example problems to help prepare you for the test. So the first one here is graphing a square root equation. And then we need to describe the transformations made to the parent graph y equals the square root of x. Here's your parent. Okay, remember that the parent, that point that we translate, is at 0, 0, which I like to call my special point. That's the point that we translate. So taking a look at number 1, we have two translations going on. We have the one under the radical, which says to translate the parent function 2 units to the left. So starting at 0, 0, we're going to go 2 units to the left. 1, 2. Okay, so we're right here. Then the plus 3 is our other translation point, which says to translate the parent function 3 units up. So we went 2 units to the left, and now we go up 1, 2, 3. Okay? Now the next thing we need to do is we need to apply the a value, which in this case is 1. So from here we go over 1, and then we apply the a value by going up 1. Now to get the other points, remember, we need our perfect squares. So we're going to go over 4. 4 is the next perfect square. So 1, 2, 3, 4. And the square root of 4 is 2, so we go up 1, 2. And then the next perfect square is 9. So we go over 5, 6, 7, 8, 9. And the square root of 9 is 3. So we go up 1, 2, 3. Okay, and there's your graph. Make sure you put an arrow on the end because it continues on infinitely. Okay, so describing the transformations, again, we have two translations. We have a translation to the left, 2 units, and we have a translation up, 3 units. Okay, our next problem. In this case, we're given the graph, and I want you to write an equation for the graph. Now, I should have said this at the beginning of the video, but my suggestion with this review is that you pause the video and you try to do it on your own first. So pause the video right now, write the equation for this graph. Okay, welcome back. So first of all, we have to recognize what type of function this is. In this case, it's a square root function. And so the square root function goes like this. Y equals a times x minus h plus k. So we just need to put the numbers in. So first of all, let's look for our translations first. So let's look for our left and right. So we went 1, 2, 3 units to the right. So this is going to be x minus 3. And then we went 1 unit up. So our k value is going to be plus 1. Now to determine the a value, we go over 1 unit and then we count to the graph. 1. So our a value is 1 and it is down 1, so it's going to be negative 1. We have a reflection over the x-axis. Okay? Hopefully you got that answer. Now let's look at the domain. Now the domain, Since this is not in context, there's going to be an arrow on the end, and it is going to go to infinity. Okay, so the domain starts at 3 and gets bigger. So for domain, our x values are going to be greater than or equal to 3. Greater than or equal to 3. So it's starting at 3 and getting bigger. Okay, our range, okay, now we need the range value, so we're looking at a 1. Okay, so, and it's getting, the range is getting smaller. So y is less than or equal to 1. The y values get smaller as you go along the graph. So there's your domain and range. Okay, let's take a look at some data. And I want to go over how to plug the data in, first of all. So we're going to go to, give me 1 second here to clear my memory. Remember, we go to Stat, Edit, plug our data in. Your X value is on the top row. That goes under L1. Your Y value is on the second row, and that goes under L2. Make sure you put the data in correctly, double check it. Sorry about this line in here. I didn't have enough room, my squares were too small, so just ignore this line in here. This is 40 and this is 10.12 here. Okay, the data should line up. If they don't, you did something wrong. Go back and check. Okay, then we go to second y equals. Okay, it's off. Our stat plot is off, so we're going to turn it on. So you're going to press enter, enter. Now we're going to set up our window, so we're going to go to window. Our x minimum is 0. I'm going to go a little bit smaller than that. Our x maximum is 50. I'm going to go a little bit bigger than that. Let's go 55. And I'm going to go ahead and count by 5s, because I think that would be a good number to go by to get from -5 to 55. Y minimum is 0. So I'm going to go a little bit smaller than that. Y maximum is 11.3, so I'm going to go a little bit bigger than that. And I think counting by 1s is fine. There's not too much space here between those. So let's go ahead and graph it. Okay. Now we should all recognize that this is not linear. Okay. If I draw a line here, it doesn't go in a constant rate like this. It curves. Okay, so this is a square root function. You should be able to recognize a square root function when you see one. Now, how do we get the equation? Well, we use the guess and check method. Remember, with linear, we can always do a linear regression, but it's not a line. With quadratic, we can do a quadratic regression, but it's not a quadratic. There's not a square root button here that we can press. So, to get the equation, we're going to go to y equals. First of all, notice there is no translation. Okay, the special point, remember up above, is at 0, 0. So there is no translation. Your data goes through 0, 0. Okay, so that means there must be either a stretch or a compression. So we need to guess a stretch or compression. So first of all, let's put in the parent and take a look. Okay, so it needs to be vertically stretched. It needs to be pulled up. Okay, so we're going to try a number greater than 1. So let's try 2. Oh, we went a little bit too far. So we know that our number is between 1 and 2. So we're going to go back and we're going to try something in the middle. This is called guess and check method. Alright, so we need to go a little bit bigger. We're getting closer. Wow. Awesome. Hit all the points. So our equation is going to be y equals 1.6 times the square root of x. Okay? So now in the problem that we just did, remember that x represented the length of the skid mark and y represented the speed of the vehicle. So in context, we have to know that this is the length of the skid mark. This represents the speed. Okay? So if we have a problem where we know that the skid mark was, say, 72 feet, okay? We know the skid mark was 72 feet. How fast was he driving? Well, 72 is going to represent x. So we would show our answer by plugging in 72 in for x, okay, to find the speed. So 1.6 times the square root of 72, and our speed is 13.58 miles per hour. Now, what if we're given the speed, say that they were going 21 miles per hour, and we want to know how long is the skid mark? Okay, well, again, we know the speed, and so we need to know that speed is y. So that means the speed goes in for y, and we're going to solve for x. So we'll have 21 equals 1.6, and I expect to see this work on your paper. Okay, we're going to go ahead and divide both sides by 1.6. So 21 divided by 1.6, we get 13.125 equals the square root of x. Now that the radical is by itself, we can square both sides. So the square cancels out the square root, and our skid mark, plugging this into our calculator, is going to be 172 approximately. So I'm going to do an about 172 feet. And that's how you answer those types of questions. Okay, since we're getting close to the 15-minute mark, I'm going to go ahead and start a new video, one that involves solving square root equations, which we kind of just saw, and one where we're graphing an equation and its inverse and writing the equation of the inverse. So, look for the review part 2 of square root functions.